Hello everyone. In this session, we will see how OE init build environment script works and what is the content of the build directory. So OE init build environment is a script which set up the open embedded build environment. What it does is it will create the build directory. It takes an optional parameter. So we can specify the name of the build directory. Else by default, it will use the build as shown here. This script needs to be sourced to use it. So if we see the environment variables, before now let's source this script. I'm not giving any name here, so it will directly map it with the existing build directory. As you can see, this BB path is updated with the build directory name. This variable is set BB extra wide. Apart from this build dir is set. Okay, this is the BB path where the beatbag is going to build. This is the build directory name. This will be used across the build. And the path variable is set with this OK scripts and beatbag bin. So this is what changes when we run this OE init script. Here this script path is also set. So this contains scripts which used to set up the environment, development tools, and tools to flash the generated images on the target. So what we see is this script, when we source it, it modifies the environment, add environment variables used by build engine, and create a build directory where all our images will be placed. As as you see, there are some common target mentioned. Core image minimal is most of the people are used when they first trigger the build. So it is a small image to boot a device and have access to core command line commands and services. Same as the SATO. The SATO is a genome based, mobile based user interface. This is an addition to this. Apart from that, we can create a tool chain so that this can be used to build any application without using Yocto for the host only. And this meta ID support will generate a cross tool chain, which will be used to create application and binaries for the target. Now, as we did source, what we know is we will have access to beatbag. Apart from beatbag, lot of other tools are also we can use. So it's just not the beatbag, but several other tools are also there. This beatbag is to trigger a build. It is for build engine. But this beatbag layers is used whenever we want to modify or create any new layer. If you go to beatbag help, we will see what all the options beatbag accept. So let's just go through some common options. The version is used to show the version number. This is useful when you pull some newer changes from upstream, and sometimes compatibility issue is there. So this will pop up. This hyphen k is used when you assume that this build may have some errors, but still you want to finish the build. Whenever any error occurs, normal build will fail, and it won't further build the remaining applications or packages. But when this hyphen k is used, whatever is failed, it will put it in a log, and it will uh, continue the build uh, as much as it can without stopping. Hyphen f is used whenever you want to force something. So in some cases, when you build some application like Vim, you do bit-bake Vim. Now Vim is completely built and build finishes. Again, whenever you trigger it, it won't build again because you have already built it. So state caches will have the entry. Now you want that to be forced. So you can specify hyphen f command. So again, it will build it. It won't look at the state caches after that. Debug is used if you face any error and you want to see the behind the curtain stuff. The dry run will not execute. It will just go through the motion. It will show what is the output and all. It won't build it. Just it will just mimic what it will do. Okay, now we will go to bit-bake layers hyphen help. This is bit-bake layer utility. What it can do is when you specify show layers, it will show all the layers present in bblayer.conf file. Now what all the recipes are available, you can mention this sub command. It will display that stuff as well. To add your existing layer, you can simply use this. Instead of modifying bblayer.conf manually, you can use this command. It will add an entry in that conf file. You don't have to do it manually. Same way you can remove any layer. Now if you want to try to create your own layer and to do some research on that, you can use this create layer. So it will automatically create a layer and with some example recipe as well. We'll see that later. Now we are in the build directory. What all the folders we will have. On the first time, we will just have the conf directory. This all will be created after you trigger any build. So this conf directory will contain configuration file, which are image specific and layer configuration file. You see there are 3 files. bb layers will have the layers information. Local.conf will have the basic environment variable set, which will affect the whole build. So these whenever a variable is set in local.conf, it is applied at global level. Globally, it will affect all the builds trigger. The downloads directory will have downloaded upstream tarballs of the recipe used in the build. Hashtag caches will have the caches used by all builds. Whatever are trigger, it will have the information of whatever is built and whatever is left. Temp directory holds all the build system outputs. Temp build stat will have build statistics for all packages build. Build statistics means CPU usage, elapsed time, host, timestamps, etc. All information will be kept here. as I haven't created any image full, so the deploy folder is not there, else we will have one deploy folder here, which will contain the final output of the build. So if you create an image, deploy folder will have one folder inside it called image. This will contain the complete images built by Open Embedded Build System. And these images are used to flash the target. Apart from that, if you create any SDK, the deploy folder will have one more folder called SDK and it will have that inside it. You see work directory here. This is a set of specific work directories split by architecture. If you see, this build is created for Camo x86-64. Now, if you change the machine and create the build again, it will have one BeagleBone, Yocto, or some other machine, whatever you specify, it will have that work directory for that. These are used to unpack, configure, and build the packages. It will contain the patch source, generated object, and logs. So whenever you do bit to some package, uh, the tarball will be kept at downloads, but it will unpack it here in the work directory. It will apply patches, configurations, and everything will be done there. And the final output of that specific binary will be kept in work directory itself. Apart from that, sysroot directory is there. One more directory will be created, named just sysroot. It will have shared libraries and headers used to compile application for the target and as well as for the host. So that will contain libraries and headers. Now let's go to conf directory. Let's examine that bblayer.conf first. Here you see this will contain all the layers included. By default, we will have meta Poki, and meta Yocto BSP. Meta will provide all the base metadata. Meta Poki will provide the metadata for Poki distribution, and Yocto BSP will provide the metadata for BSP configuration. What all the machines we will see in local.conf, all that BSP configuration will be placed in meta Yocto BSP. So these three layers are important by default Beatbake will add it. Here you see all the machines. So the BSP configuration for this all the machine will be added by meta Yocto BSP. By default, Camo x86-64 is there, but we have the support for BeagleBone as well by default. The path where download will be placed, the path where stat caches will be placed. These all variables can be overridden. So we can specify our own download directory. We can change that directory structure. We can do everything. We need to specify that in local.conf. Same way, temp directory can be changed. The name can be changed by default. This all information are by default. Distro we have Poki. If you want to create Debian package or RPM packages, this is the place where you can specify. This all information are by default. If you have your own layer which can specify some other thing, we will have some addition to this. Now this extra image features, what all the default values it support. If you want to debug something, By default, debugging symbols will be stripped from your binaries. So if you add this, it will add symbol information for debugging and profiling. Same way, if you want source code in your rootfs, you can specify this. This will pack all the source code. Same way, if you want any development tools like GCC, Make, PKG config, by default, it won't be there. We have to manually add. But instead of manually adding, you can just specify this here. So it will add all the necessary development tools. Same way, debugging tools like GDB and Asterisk will be added by applying this. If you have configured your local mirrors, you can specify that in asset mirrors. So all the pre-built stuff, it can pull directly from here, or whatever path is specified. So it won't do the download, patch and everything again and again. Apart from these three, this machine variable is important. That is what we normally change to some other value. Apart from that, two other variables are there called BB number threads. And one more is there. BB number thread will state how many tasks Bitbake should perform in parallel. So to speed up the build, this variable is used. By default, it will have the value as the number of CPUs on the system. If you have quad core CPU, the value will be set as 4 by default. Or if you have an octa core CPU, it will have the value as 8. So when this build is triggered, all the other application need to wait, or it will lag sometime, as Bitbake is using all CPUs at a time. This can be changed. Normally, if we have quad core CPU, instead of 4, we give 2, so that Bitbake can use 2 cores and another 2 cores can be used for some other work. Same way, for compilation, there is one more variable is there, which is called parallel make. It mentions how many processes should be used when compiling. So BB number thread is for Bitbake whole task execution, but parallel make is used for compilation only. Same way, it is also set to the number of CPUs on the system. So this can be also modified according to our need. This is what all needed to understand before starting or triggering any build. Next session, I will go through the core image minimal, how it builds, what all the packages it accepts, and how can we add other packages to it.